This is the second part of a Level 2 Functional Skills Maths paper from NCFE. In this part, you can use a calculator. We'll have a look at the questions one by one. Activity 2, basketball. Lottie plays basketball. She does some shooting practice. She takes 75 shots. 33 of these shots go in the basket. What percentage of her shots go in the basket? So 33 out of 75. If we do this in the calculator, meaning 33 divided by 75, it gives us 0.44, which is, as a percentage, 44%. So moving the decimal point 2 places to the right, or multiplying by 100. Or thinking how many pennies there would be in a pound if this was money. The table shows the number of points Lottie scored in games 7 to 12 this season. Her median score for these games is 25% higher than her median for games 1 to 6. After game 6, Lottie's dad said he would increase the money in her money box by 20% each time she scored more than her median for the first 6 games. Lottie started with £50 in her money box. How much money will she have after game 12? So the first thing to do is to work out the median for the games from 1 to 6. And we'll do that by finding first the median for the games 7 to 12. So looking at these scores, let's put them in order. 6, 6, 10, 10, 12, 14. We have 10 and 10 in the middle, so that means the median for these is 10. And this is 25% higher than the median of the games from 1 to 6. So let's work that out. So there was this 100% amount, which we don't know, 100% of the median itself. And there's been an increase by 25% extra. So this whole thing is equal to 10. We are looking to find the 100% amount. Now, with a calculator, you do perhaps a different method, but we can try and figure out how many 25s would fit into 100. So we get equal divisions. So we'd have 5 lots of 25% for the whole thing. So if I split 10 into 5 equal parts, I get 2. So that means this is equal to 2, this is 2, this is 2, 2, 2, and so on. So the increase has been equal to 2. The 100% amount, which is what we are after, is equal to 2 and 2 and 2 and 2, which makes 8. So the previous median was equal to 8. And if you want to double check that, find 25% of 8, which is a quarter of 8, and that is equal to 2. If you add that on top of 8, it gives you 10. So let's have a look at these now. When has she scored more than 8? She scored here, 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 and here. So it is 4 times. Now, what the question is saying is that the money in her box will increase by 20% each time she scored more than her median for the first 6 games. So that means 20% of the previous amount. So we're talking about compound increase. So we'll write the formula. So we're starting with £50 times 1.2 because it's 20%. To the power of 4 because we've got 4 occasions when this happens. Plugging this into the calculator, we get 103.68. So £103.68. And we've answered the question. A player's true shooting percentage, TS percentage for short, for a game is calculated using the following formula. So TS percentage is equal to 50p divided by 0.44f at A, where P means the total points scored, F is the number of free throw attempts, A is the number of other goal attempts. In her last game of the season, Lottie scored a total of 15 points, attempted 8 free throws, made 17 other goal attempts. Use the rule to calculate Lottie's TS percentage for this game. So, $50 times P, which is 15 in this case, all divided by 0.44 times F, which is number of free throw attempts, and that is 8. Add A, which is number of other goal attempts, which is 17 in this case. So we'll do 50 times 15, which is 750. Now, Vidmas tells us we need to do multiplication before addition. So we're going to go 0.44 times 8 first, which gives us 3.52, and adding 17 to that gives us 20.52. Dividing now 750 by 20.52 gives us 36.5497 and so on. So let's round it to 36.55. Note reads that the best angle to launch the ball from for free throws is 50 degrees. Calculate the angles A, B, and C. These are not drawn accurately, so there is no point in measuring them with the protractor. And then we've got to tick the ones which are 50 degrees. So looking at A, we've got both angles adding up to 90 degrees. This is already 40, so 90, take away 40, it's going to give us 50. And that is what A is equal to. Looking at B, we've got the 3 angles on a straight line, which means 180 degrees in total. So if I take away the 35 and 65, that's going to leave me with B. 35 and 65. They add up to 100. So 180, take away 100, leaves me with 80 degrees. So B is equal to 80 degrees. Looking at C, we've got the 3 angles in a triangle. So they would add up to 180, so 65 and 65. That gives us 130. 180, take away 130, leaves us with 50. So C is equal to 50 degrees. So as you can see, A and C are both 50 degrees, so we're gonna tick them both. This is a scale drawing of a basketball court. The scale is 1 to 400. The diameter of the center circle on the diagram is 0.9 centimeters. So we're talking about this one here. So this is on the diagram. Work out the actual area of the center circle in meters squared. Use pi equals 3.14. So we know that the scale is 1 to 400. So 1 would be on the diagram and 400 would be the actual area or length. So now we've got that being equal to 0.9 centimeters on the diagram. So we're going to work it out in reality. To get from 1 to 0.9, we've multiplied by 0.9. So we're going to do the same on the other side. Using a calculator, 400 times 0.9 gives us 360, and that is centimeters. Because we haven't got any units here and we use centimeters here, so that is going to be the same. Now we can work out the area using pi r squared, where pi is 3.14. Now this is the diameter, 360 centimeters. If I divide it by 2, it's going to give me the radius. So 360 divided by 2 gives me 180. Now that is 180 centimeters, and I'm going to work out the area in squared meters. So I'd like to convert this into meters now. So 180 centimeters, what is that equal to in terms of meters? 1 meter is equal to 100 centimeters. 180 centimeters will be equal to 1.8 meters. So in other words, dividing by 100. So I'm going to put here 1.8 squared. And plugging this in the calculator, we get 10.1736 square meters. There are 15 players in Lotto's basketball team. The table shows information about the players. The coach chooses a forward at random to take a shot. What's the probability that the player chosen is over 1.8 meters tall? Give your answer as a fraction and as a decimal. So we're focusing on forward, this row here. So the shot can only be forward. And we are asking about the probability that the player chosen is over 1.8, and that would be this one here, 3. So it's 3 out of 3 add 5 add 0, which gives us 8. So 3/8. If we do this in a calculator, we divide it by 8 gives us 0.375. Activity 3, road safety. Jed is 65 years old. He drives a car but thinks his eyesight is not as good as it was. The scatter diagram shows the relationship between the ages of the drivers and the maximum distances at which they can read road signs. What fraction of the drivers over 65 can read a road sign at over 400 feet? So we're focusing on the drivers over 65. This is the point at 65, so above that, and then we're going to look at the ones who can read a sign at over 400 feet. So that is at this point here. So it's only 3 of them, as you can see, 1, 2, 3, out of 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 of them who are over 65. So 3 12s is the same as 1 quarter. Jed says, using the scatter diagram, I predict that between the ages of 25 and 65, the maximum distance at which people can read a sign reduces by over 50 meters. Is Jed's prediction reasonable? Use the scatter diagram in 3.8 to show how you decide. Use the conversion. 1 meter is equal to 3.28 feet. There are different ways we could tackle this, but first of all, since there is a claim that the distance that people can read a sign at reduces by 50 meters, and in the scatter diagram we're working with feet, I'm going to convert 50 meters into feet first. So 1 meter is equal to 3.28 feet. What about 50 meters? So it's 50 times larger. So we'll multiply 3.28 by 50, which gives us 164 feet. Now let's predict the distance at the ages of 25 and 65. Work out the difference and see if that is over 164 feet. To predict, I'm going to need to draw a line of best fit. trying to keep an equal distance between the points on both sides. So roughly about here. So we're looking between 25 and 65. So if I go up to 25, so this is 520, and going to 65 is about 395. So let's work out that difference. So 520 take away 395 gives us 125 feet. Now we needed this to be 164 and over in order for the prediction to be true, and in fact it is not. So is Jed's prediction reasonable? We're going to say no. A Department of Transport survey collected data on the percentages of cars travelling at different speeds on a motorway. The table shows the results of this survey. Work out an estimate for the mean speed. So we've got a range, so that means we need to work out the midpoint. So between 40 and 50, that would be 45, which we're going to multiply by 4. And then between 50 and 60, we get 55 multiplied by 13. Between 60 and 70, we get 65 multiplied by 36. Between 70 and 90, we'd have 80 multiplied by 47. So that is in total 6,995. We're going to divide it by how many there are, and that of course adds up to 100%. So 6,995 divided by 100, that gives us 69.95 miles per hour. Some drivers driving over the speed limit are invited to go to a speed awareness course instead of getting penalty points. There is a maximum speed at which a person can drive and be invited to a speed awareness course. This speed is given by this formula. M is equal to 1.1 L at 9, where M is the speed in miles per hour, L is the speed limit. Calculate M when L is equal to 30 miles per hour. So we'll do multiplication first. And using a calculator, go 1.1 times 30, which gives us 33, and then add 9. So that makes 42. The table shows the number of people attending speed awareness courses each year from 2014 to 2018. Jed says the mean number of people attending each year for 2017 or 2017 and 2018 is over 3% higher than the mean number of 2014 to 2016. Is Jed right? Show how you decide. So we're looking at two different means. So we're going to split these into the years to 2017 and 2018, and the years from 2014 to 2016. So if I add these three together and divide them by 3, it gives us 1383410.333. Let's repeat the process with the last two. And it gives us 1429707.5. So it is suggested that there is a 3% increase. So we'll go from the higher number, which is the last one, taking away the other number, and then we'll divide it by the original, which was 1383410.363. So doing this, we get 46159.137, again divided by 1383410.363, which gives us 0.03336 and so on. So turning this into a percentage, meaning multiplying by 100 or moving the decimal point 2 places to the right, we get 3.336 and so on. So this is higher than 3%. So is Jed right? Yes, he is. Activity 4, printing. Rani is on placement at a printing company. The company has an order for some leaflets. Each page will have a rectangular area of text with a 2 cm margin around it. The printer can fit an average of 3.9 words of text per centimetre squared. There are 2,000 words in total. What's the minimum number of pages that the printer needs? You must show your working. So let's work out the text area. So this is 13, but if I take away 2 centimeters on each side, then I'm going to be left with 9 centimeters. And the same thing here, it's 20, but I take away 2 and 2, which is 4. That's going to leave me with 16 centimeters. So I'm going to multiply 16 by 9. Which gives us 144 centimeters squared. 3.9 words fit into each centimeter squared. So how many will they fit in 144 centimeters squared? So we're going to multiply 3.9 by 144 to see how many words will fit in one page. And that is 561.6. Now 2,000 words are needed in total, so 2,000 divided by 561.6. Let's see how many pages, and that gives us 3.561253 and so on. So we're going to say 4 pages, because of course we can't leave some of the words out. Another leaflet is folded like this. What's the maximum number of printed pages the leaflet can have? So if you think of it, you can print on both sides. So 1, 2, 3, then another 3 on the other side. So that makes 6. The printer offers 2 discounts, offer A and offer B. Offer A says buy 2 boxes of leaflets, get the third box half price. Offer B says 5% off the total price. A customer wants to buy 3 boxes of leaflets. Which offer is cheaper for the customer? Show how you decide. So if we try and represent the boxes, 1, 2, 3 of them, we're getting the third one half price. So basically you're getting a discount that is 1 out of 6, so 1/6 off with the first offer. And if you convert this into a percentage, 1 divided by 6 gives you about 0.16, which is roughly about 16%, and that is way higher than 5% from offer B. So which offer is cheaper? Let's say offer A. Ran is asked to work out the average number of orders per month last year. The table shows the number of orders each month. Work out both the median and the mode for Rani and give one reason why the median is the better average for her to use. So let's put the numbers in order. The lowest is 45, and then another 45. We then get numbers over 100, so 125, 129, 132, 138, 146, 148, 180, 182, 195, 202. Crossing them out both sides. Got 2 numbers in the middle. So 138 add 146 and then divide the answer by 2. And that gives us 142 as the median. Looking at the mode, which is the number that occurs mostly, well, the only number that repeats itself is 45. So mode is 45, which is too low, is the lowest value. So the reason why the median is a better average to use, we're going to say the mode is too low. Or you could say that the median is the better average. It's more central, it's more in the middle. The company's income in 2019 was £863,490. This was 7% higher than in 2018. Work out the company's income in 2018. So 2018 is the original. So we are gonna represent that as the 100% amount, and we don't know what it was. What we know that is in 2019 there was a 7% increase, and this total is equal to £863,490. So what we're going to do is divide this by 107, because that's how many percent that represents, and then multiply by 100 to get the original amount. So 863,490 divided by 107 gives us 8,070. So that is the 1% amount. If I multiply it by 100, I'll get the 100% amount. So 807,000 is the answer. The company also prints t-shirts. 2/11 of the t-shirts are white. 1/3 of the remaining t-shirts are black. What is the ratio of white to black t-shirts? So we've got white and we've got black, and then other ones as well. So 2/11 are white, so 2 out of 11 in total. So that means that black and any other color will make, or will be equal to 9, because 9 and 2 makes 11. So this is equal to 9. Now we're told that 1/3 of the remaining t-shirts are black. So 1/3 of the 9. 1/3 of 9 is equal to 3. So 9 divided by 3 gives us 3. So there are 3 black t-shirts in terms of the ratio. And then, of course, this would be 6, but we're not required to work it out. What we need is the ratio of white to black t-shirts, which is 2 to 3. And this is the end of the paper.